Hi guys, welcome back. So we are going to be going over 4.4, number 73, and number 34. So take a second to actually try these problems out on your own and then check back in for a solution once you have either gotten frustrated or gotten done with the problem. All right, see you soon. Okay, assuming that you paused the video, let's keep going. So for this first one, I have the integral from 0 to 1 over root 3 of t squared minus 1 over t to the 4 minus 1. And if this was a derivative problem, this would be so easy. This would be sweet because you'd just be like, oh yeah, of course, use the quotient rule. There's a quotient there. But the problem is that there's no quotient rule for taking antiderivatives. So what we need to do here is we need to rewrite this as some kind of a power rule thing. So the way that we do that, or maybe not power rule, but rewriting it in some way so that we can actually integrate the function. So the way that you want to proceed is by actually factoring and canceling any common factors between the numerator and denominator. So what we can do is we can factor the numerator as t plus 1, t minus 1, and we can factor the denominator as t squared plus 1, t squared minus 1. And t squared minus 1 is, again, t plus 1, t minus 1. And so these guys cancel out. So you're left with the integral from 0 to 1 over root 3 of 1 over t squared plus 1 dt. You might want to be a little bit careful here because you technically don't have the same function here as here because you canceled those common factors. So you do want to make sure that none of those cancel terms would have a 0 or a root in the interval that you're integrating over, because if it does, then you've got an issue because this function isn't continuous on the interval. So let's just make sure that's not happening. I'm going from 0 to 1 over root 3. Root 3 is bigger than 1, so 1 over root 3 is smaller than 1. These zeros are occurring at -1 and +1, so they're not occurring inside of that interval region, so we're safe. So now we just need to think about this integral, and if you look over your derivative rules, what you'll see is that the derivative of the arctangent function is 1 over the argument squared plus 1. So if I want to take the antiderivative of 1 over t squared plus 1, I use the arctangent function to do that. So this is going to be the arctangent of t, and we're going to evaluate it at 0 and all the way up to 1 over root 3. So to do this, I need to figure out what the arctangent of 1 over root 3 is. And the arctangent is 0. So the arctangent of 0 is the angle that when you take the tangent gives you 0. That happens whenever the sine is equal to 0. And in this case, arctangent, that angle should be 0. So arctangent 0 is 0. Now for 1 over root 3, we want to think the same thing. What angle, when I take the tangent of it, gives me 1 over root 3? And if you can remember your special triangle that has the pi over 3 and the pi over 6 in it, you'll recall that the angle that gives you a tangent of 1 over root 3 is actually pi over 6. And so our result is pi over 6. looking at number 34, for number 34, I have a bunch of functions, and they're all trig functions, and they're being divided, and the sad thing is that I don't have a quotient rule or a product rule or anything that I could use to work with those. So what I need to do is I need to make it look like something I can take the integral of. And the best way of doing that is by trying to apply a trig identity. So I'm going to start by factoring out this sine term that's appearing in both of these places. This becomes sine theta times 1 plus tangent squared theta. Now you should recall that one of your Pythagorean identities is that 1 plus tangent squared theta is actually equal to secant squared theta. So the 1 plus tangent squared in the numerator can cancel with the secant squared in the denominator by that Pythagorean identity. So now I have the integral from 0 to pi over 3 of sine theta d theta. The function whose derivative is the sine of theta is the negative cosine of theta. I'm going to plug in pi over 3, plug in 0, and then subtract the results. Negative cosine pi over 3 minus negative cosine of 0. Negative cosine of pi over 3 is 1/2. Negative 1/2. And then this would be minus negative 1. Negative 1/2 minus negative 1 gives you 1/2. And that's our result. All right, see you guys next week. Thank you.